Good day. Welcome to the physics exercises channel. So in this video, we will solve the problem that's listed on the upper left corner of the screen, or that's shown rather. A sled of mass m is given a kick on a frozen pond. The kick imparts to it an initial speed of 2 meters per second. The coefficient of kinetic friction between sled and ice is 0.1. 0.100. Use energy considerations to find the distance the sled moves before it stops. Okay, so to start this problem, we draw a picture. Sorry, that doesn't draw. I need a pen. So let's say here's the surface on which the ice is, and I'm just going to, this rectangle represents the sled. It has mass m, and it's given a kick, okay? But what that really means is that we impart an initial speed of 2.00 meters to it. Meters per second, sorry. Okay, so the data that we have so far is that the mass is m. Okay, that's not really data, but v initial is 2.00 meters per second. Okay. The coefficient of kinetic friction is 0.100. So basically this object slides in that direction, but there's a force acting on it, which is in that direction, and that's the force of friction. And let us, before going on, draw a free body diagram. Okay, so I will draw it here. Free body diagram. And the free body diagram shows all the forces acting on the object. Okay. So I moved the object around. So basically our free body diagram, I represent the object as a point. And we have mg, which is the gravity force. We have the normal force acting upwards, and we have the friction force acting opposite the sense of motion. Okay? And what do we learn from this? Actually, we can put this together to find what the friction force is in terms of the gravity. Because from the situation, we know that, okay, first of all, there's an equation of motion in the vertical direction. And the equation of motion in the vertical direction is n minus mg equals 0. Okay, in the horizontal direction, the equation of motion is F equals ma. Okay, F equals ma. Now, I have a suspicion about this problem, which I'll share with you at this point. They didn't give us a mass, okay? So I suspect somewhere the mass will have to cancel in the final result. Okay, that's just insight into having experience in solving problems. But let's see if that happens. I don't know it at this point. Okay, however, we know one thing, that the friction force is equal to the friction coefficient, kinetic friction coefficient, which actually is given. Let me write that among the input data, which I forgot, 0.100, okay, times the normal force. And from this first equation of motion, we know that the normal force is equal to the gravity force. So we know the magnitude of the friction force. Okay, at least if we knew m, we would know it. Okay, okay. Now, so we want to calculate the distance the sled moves before it stops. Okay, and what we know is the following. So now I'm going to scroll up a bit, so some of this will disappear, but I'll remind you of all the important things. Okay. So if I scroll up a bit, initially the object has a kinetic energy, mvi squared over 2, okay? And when it stops, the object has a kinetic energy of 0, of course, okay? And this means that there's work done on the object, and that work is, of course, kf minus ki, which makes minus mvi squared over 2. Okay, so we have one relation which we will use, namely that the work done on the object is given by this formula in this case, okay? But we have another formula for the work which comes from the fact that we know that it is the friction that is doing the work, okay? So we will write the work in another form, because the work is minus F, which is friction, times the displacement. And it is actually the displacement that we are interested in. Okay, so let me scroll up a little bit further. I still have my friction up here, so I didn't scroll up too much so that I can still see what I need. Okay, so minus mu k mg times d, and these two are equal because they are both work expressions. So from these two, I can equate mvi squared over 2 to, I got rid of the minus signs, mu k mg, g times d. And indeed, if you look at this expression, then the masses cancel, okay? So basically, from this, we actually derive that the displacement, which is actually what we're looking for, is vi squared divided by 2 times g times mu k. Sorry for all this, mu k. Okay, and this is basically our final answer, except it's not in numerical form. But consider d was the unknown that we are looking for. Do we know everything else? Vi is given in the problem. If I scroll back, it's 2.00 meters per second. Okay, so let me write here. Vi is 2.00 meters per second. Mu k was also given in the problem. Mu k is 0.100. It has no units because it's a coefficient. It's a friction coefficient. And g is the gravitational acceleration, which is a known number. Okay, so g is also known. So this number can be calculated. Okay, I will approximately calculate it, assuming that g is 10 meters per second squared, not 9.8, okay? If you want a more accurate result, you can use 9.8. So let's calculate d. 2 squared is 4.00 divided by 2 times 10 times 0.1. Okay, so 10 times 0.1 makes 1, so we can cancel this. So it looks like the object will slide for 2 meters. Okay, that's an approximate number, first of all, because I used 10 meters per second squared. Okay, mainly that's the reason why this is an approximate number. Okay, but you can get a more accurate result by using 9.8 instead of the 10. Thank you very much. Have a nice day.